solve another Leetcode problem. 2398, maximum number of robots within budget. The problem is that we are giving a charge times array, and we are also giving a running cost array, and both of them are equal to n. I mean, the length of the charge times equal to the running cost. Yeah, so for example, for the first item, the charge time is 3 and running cost is 2. But what are we going to return? We're going to return the maximum number of consecutive robots you can run such that the total cost does not exceed budget. So we are also giving a budget, for example, it is 25. So if we are just to choose the first element, for example, that is easily 3. So our charge time is 3 and the running cost is 2. And the formula is the maximum of charge times. It is 3 plus this k. K is the number of elements. Yeah, so plus this k times the sum of them, it is 2. So 3 times 2, it is 6. It is okay, but it is not the largest. Yeah, so let's just check what is the largest. So the largest is going to be 3, 6, and 1, because 3 plus 6 plus 1, it is yeah, let's just calculate. So the charge time, the maximum, we're going to choose the maximum. It's going to be 6, and it is this 6. And for the running cost, because there are 3 elements for the running cost, and the sum of them are going to be 6. So it is 6 plus 6, 3 times 6, it is 24. So 24 is less than budget. It is less than equal to budget. It is okay. So currently, the current window length, the maximum is going to be 3. So we're going to return the final result. So if it is 4, the maximum is still 6. But as you can see, the sum of them is going to be 10. 10 times 4 going to be 40. 40 plus 6 going to be 46. It is going to be more than 25. It is not okay. I think there are too many different ways to solve the problem, but the best solution is going to be the monotonic queue, because we are going to check the largest element in a range. Normally it is a monotonic queue problem. We can solve it by using the sorted list, or we can solve it by binary search, but both of them, I think at least it's going to be n log n time. But for monotonic queue, we're going to use just O(n) time to solve it. Basically, we are going to keep a monotonic decreasing queue, because the decreasing queue is going to be the charge times, because in this array we are calculating the maximum element. And at the same time, we're going to check the running cost, I mean the total numbers. And these total numbers can be solved by using a sliding window. So we're going to connect. Normally, the monotonic queue is connected with sliding window, but we can use them together to keep the running cost and to keep the maximum element inside a window. If inside a window, we can find the maximum element, and we can also find the sum of the element. So the number of element is k. So k times s plus m plus k times s. If it is less than the limit, if it is more than the limit, yeah, so we're gonna check it. We're gonna shift the L pointer, and we're gonna keep the minimum window, and the final result is gonna be the maximum window we can keep. Yeah, so let's now just try to solve it. So I'm gonna prepare a result and a left pointer and a total, and I also need a monotonic decreasing queue. So it's gonna be 0 for result, left pointer, total gonna be 0, and queue gonna be the queue. Now we are going to check the monotonic queue. So for I, I'm going to check the charge time and the running cost. So it's going to be represented by C and R. C is the charge time and R is the running cost. So I'm gonna enumerate it in a zip of running cost, and yeah, so in a zip of charge time and running costs. First of all, I'm gonna keep a monotonic decreasing queue, so I can check while q and my current value. So it is the charge time. It is C. If the C is more than the charge times with q minus 1, so this is the basic monotonic queue structure. First of all, it's gonna be a monotonic decreasing stack structure. So we're gonna pop out the element. So q dot pop. We're gonna pop out the element. After that, we're gonna append the index. Yeah. Now for each of the time, we're gonna keep the total value. Total value is the total running cost inside a window. So currently, yeah, from the left side to the right side, the left pointer is 0. But for the total, I will keep plus all the running cost. So it's gonna be total plus r. Yeah. Now I'm going to check if it is out of the limit. And I need to check the formula. So the formula is the maximum charge time. So what is the maximum charge time? It is Q0. So we have to check while the Q exists, and Q0 times the window. The window is I minus L plus 1. And we also need to times the total, the sum of them. Yeah. So if this is more than limit, so where is the budget? So if this is more than the budget, so we're gonna check it like a sliding window. So first of all, we're gonna check the top of the element. So this is not Q0. This is the charge time with Q0, because we need to get the value, the maximum element, not the index. Yeah. So if this index Q0 equals to L, I mean the left pointer. So for the charge time for the monotonic decreasing Q, if it is equal to the first element, basically we want to pop out the first element. If it is equal to the index, it means we need to pop out from the left side. So Q should pop from the left side. Yeah. But no matter if we pop out the Q or not, we have to keep track of the total. So the total would be minus, yeah, because we're gonna take out the first element. So for example, if this 2, we're gonna take it out. Yeah. But for the first element, this is 3. Maybe yes or maybe not, because we are not sure. This is a monotonic decreasing Q. Maybe this 3 has already been popped out from here. So this is why we have to use if check. Yeah. But definitely for the running cost for each of the sliding window check, we have to minus the value. So what is the value? So the value is coming from the running cost, and the pointer is from the left side. It is L. So L would be updated to plus 1. Yeah. Now we can record the result, and it's going to be maximum of I minus L plus 1. Finally, we can return the result. And this is going to be the entire code. Let me just check if there's something wrong. We prepared all those variables, and we have the monotonic decreasing Q, and we keep the total value, and the total value would be minus, and we update the left pointer. And I think it's okay. Let me just run it to check. There's something wrong. Yeah, this is not I expected, but let's just check what is wrong with it. Yeah, my sliding window is only 1, but I need to have 3. Let me just check it. So this is my monotonic decreasing Q. This is for the time. Append is I, and my total value plus the R, and while Q exists, and start time with Q0 times I minus L plus 1. Yeah, I think I did the formula wrong, because this is a plus, but I used the times. This is something typo I made because I didn't check it carefully, because it is the maximum of such time plus K times the sum. So this is K times the total value. Yeah, now let me run it to check. Yeah, as you can see, now it works. Now let me submit it to check. As you can see, it passed all testing cases, and it's pretty fast because we used ON time, because this is a monotonic decreasing Q structure. And thank you for watching. See you next time.